lesson is going to be on writing the equation of a tangent line to a curve. As we've talked about before, when you write the equation of the line, remember that you always need two things. You're going to have a point and a slope. And since we're working with tangent lines, we're going to be working on the slope of the tangent line. And if you remember back to when we first defined derivatives, that's what the derivative is. So that's how this is going to tie into what we've been doing. All right, so let's look at a couple examples. Let's say that I want you to find the equation of the tangent line to the curve y equals 3x cubed minus 5x squared plus 2. And I want you to find that at the point x equals 1. All right, so we need a point and a slope. Well, we already have the x value for a point, it's 1. So the next thing we need to do is find the y value. So to do that, we're going to substitute back into our original equation and get that y is going to be 3 times 1 cubed minus 5 times 1 squared plus 2. It's going to be 3 minus 5 plus 2, which is 0. So now we have our ordered pair. It's going to be the point 1, 0. And then we need our slope. Well, our slope is our derivative. But if I look at this, the derivative is going to be 9x squared minus 10x. Now, we don't want to use that equation for the slope, so we'd like to have that to be a number. Well, if I knew a value for x, then I could substitute that in and find out what the slope would be. Well, we know that we want to evaluate this when x is 1. So then we're going to put 1 in for our x value and finish simplifying that. So we get 9 minus 10, which is negative 1. So our slope is negative 1. Now that we've got our 2 points, we can write our equation. So you either have the option of using y equals mx plus b, or your point-slope form, which is the one I use all the time. Y minus y1 equals m, x minus x1. And now I'm just going to substitute in. My y point was 0. My slope was negative 1. My x point was 1. So I have y minus 0 equals negative 1, x minus 1. Now I will point out that if you're on the free response part of the AP test, you could stop there. If it's multiple choice, a lot of times they're going to go ahead and put it in slope-intercept form. So you'd be looking for y equals negative x plus 1. And that would be the equation of the tangent line. All right. Let's try one that's got some trig in it. Y equals 4 cosine x plus 3. That's our line, or our function. We want to find the equation of the tangent line at x equals pi over 2. All right, so again, we need an x and a y. We know what x is. So let's substitute that in and find out what y is. 4 cosine pi over 2 plus 3. Remember from your unit circle, pi over 2 is here. That's the ordered pair 0, 1. Cosine is the first number, so the cosine of pi over 2 would be 0 plus 3. So that's going to be 3. So our y value is going to be 3. So we have the point of pi over 2 for x, 3 for y. Then we're going to find our slope. But to find the slope, we're going to take our derivative. So y prime would be 4. Derivative of cosine is negative sine of x plus 3. So we could rewrite that as negative 4 sine of x plus 3. Again, we don't want to use that mess for our slope, so let's substitute in our x value, which was pi over 2. So I have negative 4 sine pi over 2 plus 3. We go back to our unit circle. The sine is the second value, so it would be 1. So we have negative 4 times 1 plus 3, which is going to be negative 1. It's all our derivative. So our slope is negative 1. So our equation becomes y minus the y value equals m, x minus the x value. This one gets a little ugly if we go ahead and simplify. So if I distribute, I get y minus 3 equals negative x plus pi over 2. Then I'd add 3. So your final answer would just be negative x plus pi over 2 plus 3. And that's your equation of your tangent line. All right, one last problem. We'll do that with implicit derivatives. So we have x squared y plus 3y equals 6y squared minus 2. And we're going to do this at the ordered pair 1, 1. So this time they've actually given me both the x and the y. So my point is 1, 1. I need to get my slope. So now we do what we've been working on. We take our derivative, which is going to be an implicit derivative for this. So we'll let, for this first part, u be x squared and v be y. U prime would be 2x and v prime would be dy dx. I'm going to do my Jesus fish. I'm going to have x squared dy dx plus 2xy. So that's the derivative of the x squared y. Plus, then the derivative of 3y would be 3 dy dx equals the derivative of 6y squared would be 12y dy dx minus the derivative of 2 would be 0. All right, now if we continue like we've been doing, we go ahead and solve by getting all the dy dx's to the same side. So I am going to subtract off a 12y dy dx, since I've got two dy dx terms already over on the left, and I'll subtract the 2x y. Okay, so that when I do that, that's gone. X squared dy dx plus 3 dy dx minus my 12y dy dx equals, remember that'll be gone, it's over here now, then write that down. And then I'll have a negative 2xy. Then we factor out our dy dx's. I get x squared plus 3 minus 12y, negative 2xy. Whoops, times or equals. And we divide by x squared plus 3 minus 12y. Now this is a little different because derivative has both x's and y's in it. So to get that to be a number, I need both x and y values. So if you notice, they gave you both of those at the beginning because they gave me an ordered pair this time of 1, 1. So we're going to let all the x's be 1 and let all the y's be 1. So I get negative 2 times 1 and 1, and then 1 squared plus 3 minus 12 times 1. So now simplifying that, I'm going to get negative 2 over 4 minus 12 would be negative 8. So I get positive 1/4. So that's my slope. So all the way back here, we'll put in that's 1/4. So now I can write my equation. And I'm going to leave it in point slope form this time. So it's going to go y minus the y value was 1 equals 1/4 x minus the x value, which was also 1. And again, that would be my equation of my tangent line. Now I do want to point out one thing just kind of quickly here. One option that we have that I think will make this a little faster is once you take your derivative, let's go back to this line. Okay. Let me take a few things off there. So let's take this off. Once we took our derivative and we got to here, what I think helps a lot of times, rather than moving stuff around, is go ahead and substitute your point in at that place. So once we take the derivative, let's put in 1 for x, 1 for y. 1 squared dy dx plus 2 times 1 times 1 plus 3 dy dx equals 12 dy dx. And notice what that does is it gets rid of all your variables other than the dy dx. So then you have dy dx, or 1 dy dx, plus 2 plus 3 dy dx equals 12 dy dx. Now I'm taking a few more steps than I normally would, just so you can follow. 1 dy dx plus 3 dy dx would be 4 dy dx. Plus 2 equals 12 dy dx. Then I could subtract a 4 dy dx from both sides. And that gives me that 2 equals 8 dy dx. And then divide this up by 8. And I get the slope dy dx is 1/4 again. Once you get used to substituting in the numbers first instead of working through the algebra, it actually saves a lot of time. Again, this was a few more steps than I would normally do, but I want to make sure you could follow along with me. That's all there is to writing equations of tangent lines. You're just going to take your derivative to find your slope, take an ordered pair, and then just put it into either y equals mx plus b or point slope form, and be finished.